Hello from Rose Hallman, a leader in undergraduate STEM education. My name is Jim Hanson, and I have been teaching structural analysis for 25 years. For the first few years, I taught the classical methods of analysis, but found myself struggling with an important question. In a world where practicing engineers use computers for structural analysis, are these by-hand methods still relevant? So I talked with a bunch of practitioners, and the answer was an emphatic yes. Yes, for two important reasons. Reason one, computer modeling is not always the most efficient tool, depending on what you are analyzing and what you want to know. Reason two, computer analysis results still need to be evaluated for reasonableness, and hand methods are essential for that. The issue I ran into was that none of the textbooks were structured to teach classical methods in a way that supported those two reasons. So I developed my own materials to augment an existing book. Over time, I found that I was using more material that I developed than material from the existing textbook. When I had that realization, I decided to share what I had developed with other faculty, and that leads us here. There is now a resource to help students learn by-hand structural analysis skills with a focus on how they apply in a world where practitioners rely significantly on computer-aided analysis. Probably the most significant addition to this book is skills for evaluating analysis results. I want my students to check their results, but it isn't fair for me to ask them how to do that without teaching them how. So I interviewed practicing structural engineers from all over the country in order to find out how they evaluated their results. As I processed those interviews, it became clear that experienced structural engineers are routinely using three categories of tools to evaluate their analysis results, and those tools can be taught. I started teaching those tools overtly and intentionally about 20 years ago, and the impact was immediate. As part of my research, I developed a test to measure ability to find the most reasonable analysis result and to justify the reasonableness. I used that test with my students taught using traditional content. I also used the test with practicing structural engineers. Once I started teaching these three categories of evaluation tools and incorporated them in the expectations of the homework, students cut the gap between the control group and the practitioners in half or better. One of the things that frustrated me as a student was that the textbook and instructor would present an idealized structure with idealized loads, but never showed me how to get to that picture. I wanted to know how to go from loading on a floor to idealized loading on the beams supporting it, or from pressure on a wall to point forces on frames. So I started teaching my students how to do that, and now it is incorporated here. Since our goal as educators is to help students prepare for practice, every example problem and every end of chapter problem in this book starts with a photo and description of a real-world situation that would benefit from hand calculations. Students tell me they love being able to see how what they are learning applies to the real world. One of the pedagogies that I wove into this book is metacognitive reflection. Studies have shown that practicing metacognition promotes deeper learning, so the end of chapter problems start with students guessing part of the solution and end with them reflecting on why their guess was or was not close to the answer they obtained. To help my students and graders understand how to apply the scoring rubric, I created a video demonstrating how to score a variety of responses. That video is freely available from the Instructor Resources site. As I prepared to take my professional engineering exam, I had to learn several structural analysis topics that I had never seen in class and could not find in textbooks. I learned how to distribute lateral load when there's a rigid diaphragm, what collector beams are and how to calculate the force in them, what chord forces are and how to calculate those, how to calculate approximate drift of braced frames, rigid frames, and structural walls. I made it a point to start teaching those skills to my students, so they are included here as well. Once you request a copy of this book, if you would like to start implementing but are unsure of what it might look like in your course, please reach out to me. My mission is to help you, the instructors, feel confident in your ability to teach these skills. It doesn't require a course overhaul. Switching out a few lectures and making minor additions to your in-class example problems is all it takes.